Good morning, students. Today we begin an important topic in dairy technology, thermal processing of milk. Milk is a highly nutritious biological fluid, but it is also highly perishable. In this session, we will understand why heat treatment is necessary, its objectives, types of thermal processes, and how temperature-time combinations affect microbial destruction. Let us first understand the need for thermal processing. Raw milk is nutrient-rich and has high moisture content. This makes it an ideal medium for microbial growth. The risks include pathogens, enzymatic activity, and spoilage organisms. Heat treatment converts raw milk into a safer product by improving safety, maintaining quality, and extending shelf life. The objectives of heat treatment are threefold. First, microbial safety. Pathogenic bacteria must be destroyed completely to prevent disease transmission. Second, shelf life. Reduction in microbial load increases storage stability and delays spoilage. Third, quality maintenance. Proper heat control ensures minimal nutrient loss and acceptable sensory properties. Thus, safety, stability, and quality are the core goals. Let us examine microbial safety in milk. Heat treatment kills pathogens such as those causing TB and Salmonella infections. It also reduces total microbial load, preventing rapid spoilage. When microbial count decreases, milk becomes safe for direct human consumption. Therefore, temperature control is directly linked to public health protection. The public health importance of thermal processing is significant. Disease prevention eliminates transmission of tuberculosis, typhoid, and brucellosis. Outbreak control prevents rapid spread of milk-borne epidemics. Consumer trust builds confidence in the safety and reliability of dairy products. Hence, pasteurization was historically introduced as a public health intervention. Let us compare the major heat treatment methods. HTST pasteurization, 72 degrees Celsius for 15 seconds, designed to destroy pathogens while preserving quality. In-bottle sterilization, 121 degrees Celsius for 15 minutes, achieves commercial sterility but may affect flavor. UHT processing, around 135 to 140 degrees Celsius for 2 to 4 seconds, provides commercial sterility with minimal holding time. As temperature increases, time required decreases. This is the temperature-time relationship principle. Understanding microbial destruction kinetics is essential. The survivor curve shown is logarithmic. Microbial death follows first-order kinetics. Log reduction means reduction by factors of 10. 1 log reduction equals 90% reduction. 2 log reduction equals 99% reduction. D value is the time required at a specific temperature to achieve 1 log reduction. Thermal death time is the minimum time needed to kill all microorganisms at a given temperature. These parameters guide process design. Let us examine shelf life comparison. Raw milk, even under refrigeration at 4 degrees Celsius, lasts for about 2 to 3 days. Pasteurized milk, stored at 4 degrees Celsius, lasts approximately 7 to 10 days. UHT milk, stored at ambient temperature, lasts for 3 to 6 months. This demonstrates how increasing severity of heat treatment significantly extends shelf life. The overall process can be summarized clearly. Raw milk contains potential pathogens, high microbial load, short shelf life. Heat treatment, whether HTST, UHT or sterilization, reduces pathogens. The final product becomes microbiologically safe, shelf-stable, and quality-controlled. Thus, thermal processing transforms a perishable raw material into a safe dairy product. To conclude, thermal processing of milk is a scientific method based on temperature-time combinations designed to ensure safety and quality. By applying controlled heat, we destroy pathogens, reduce microbial load, and extend shelf life. Understanding these principles is fundamental for designing safe dairy processing systems. Thank you.